Roy, you're on here?
Yes, Scott.
Thank you. So this presentation will cover ROVER Artificial Intelligence, which automatically identifies road deficiencies requiring repair using smartphone cameras deployed in vehicles. It also provides an overview of how ROVER helps create actionable GIS that allows local governments to improve service levels and operate more efficiently by enabling municipal fleets to gather important data automatically as they go through their day-to-day activities. I wonder if that can be done with sign inventories too, huh?
That's a very common question, Scott.
All right, take it away.
Thank you very much. So just let me share my screen. Just bear with me. Perfect, and if you could just confirm that you can see the screen okay, that would be great.
Yes, yep.
Excellent. So thank you for the opportunity to present here with Bayfield County at the Area GIS User Group. My name is Roy Tao. I'm the Chief Technology Officer of Visual Defense. And today we'll be presenting to you our technology that's called ROVER. And ROVER is intended to identify a lot more than just potholes. So you do see the word signs here, and that is something that will be coming as well. And just very briefly about visual defense, since we're a little bit new in this particular space, we are a company with operations in Canada and the United States. We've been in business for about 20 years. Our history comes from security systems, video surveillance for all sorts of transportation systems and areas. And from there on, we moved into artificial intelligence and mobility applications. Some examples of the types of projects we've done over the years, other than ROVER and municipal operations, we have also done security systems for airports, seaports, and transit systems. And in the 20 years we've been in business, we've developed a lot of different products that cater to different needs. We have implemented hundreds of projects around the world, and all sorts of exciting things that we've done as part of these projects. There are millions of people safer around the world thanks to the visual defense systems, and over our 20 years in operation, our systems manage more than 1 billion hours of video, which kind of leads us to why we got into artificial intelligence. And when you think about video, just think if you have 1 billion hours worth of video feeds that you're looking at, just think about the man hours that are needed in order to monitor this effectively, right? So you usually within a transit center or a security center, you have people that sit in front of screens like this, and there's videos that show what's going on. Obviously, it's not the most effective way to have a person look at all these screens, so usually it gets connected to other systems, including maps, of course, and inputs from other alarm systems or things like that. And that was a trend for many, many years until artificial intelligence has become so accessible like it is today. So Visual Defense developed artificial intelligence mainly for security operations. And we just wanted to help people understand a little bit better what's in the video. And if you look at a typical person, we are all coming in the morning, usually very, very excited, very enthusiastic, very energetic, but without caffeine and some excitement. If we're tasked with repetitive tasks, we kind of lose a little bit of concentration. And some research has shown, for example, that if you take a person and put them in front of one screen like this with 4 cameras, after 15 minutes, they would lose their concentration and not really pay attention to what's going on there. And the same could be said, of course, to driving around and patrolling roads as well. So this is just a little bit of background information about how we've transitioned from security systems to ROVER. And artificial intelligence, on the other hand, does not get tired, does not need coffee. It will give you consistent performance over the span of the day So whatever you get from it, you will get the same thing over and over and over throughout the day. And we think that artificial intelligence helps people do what they're best at: solving problems, coming up with solutions, taking care of things that need to get done, and not do repetitive tasks that could be essentially done automatically. And this is a very common video. You guys might recognize the picture here where you see people passing a ball around, and it's a basketball, they pass it around. And it was in a study that was basically, it's a very famous psychological study in '99. And you have groups of people that are sitting and they're told to basically count how many times the ball is being passed around. And throughout this video, you have a guy dressed up like a gorilla, just going in between all the people, pounding on his chest and just walking off. And at the end of the video, it doesn't ask you how many times the ball was passed around. It asks you, have you seen the gorilla? And 50% of the people say, no, we didn't see it. So when we look at municipal inspectors that are tasked to drive around and look for things, it is very likely that things are, even if they're professional, even if they're doing their best, there are limitations to what we can do. And when you're looking for one thing or doing one thing, it takes away from something else. We only have so much things that we can do at the same time. So artificial intelligence is supposed to help with that. We basically teach a computer to take a bunch of data and learn from it, improve from it. What we do is we created our artificial intelligence for the purpose of security systems. We saw a use case with Potholes, and it learns very similar to how you would teach basically a child, for example, to recognize the color blue. So you could show the child a blue cup, a blue shirt, a blue sock. You show the child a blue hat, they will say blue, you say correct, good job. And then basically they learn through examples what blue looks like. And this could be also for shapes and objects and all sorts of stuff. And just very briefly about image-based artificial intelligence, which I think could be a presentation on its own. But it is exciting, and I do know that there are a lot of very exciting applications that this is done directly with maps as well. But usually the way that it works is we have a bunch of data that we collect with things that we're interested in. We basically have people that basically teach the computer what's in the pictures. And the way that we do it is we have platforms like this where we have people basically, it's called annotating. They're basically marking in the pictures what different things are. And similar to us, we need a lot of examples to learn. The computer needs a lot of examples to learn. It could be thousands to hundreds of thousands to millions of pictures. And then in these pictures, you basically mark for the computer what are the different things that are in there. And the computer basically pulls this information, grinds it through very fancy mathematical operations to come with heuristics or rule of thumbs or basically baseline of what it thinks is associated with what it's trying to find. So for example, if we mark this plate here on this table and the computer was trying to figure out what's a plate, some of the things that the computer may identify as characteristics of a plate is that a plate is commonly white. It may identify that a plate is mostly round, and it may identify that a plate, relates typically to a brown background, but not always, right? And then there's thousands to millions of these features in our models that we create, so that basically the sum of all of these things together kind of helps the computer to understand that this is a plate. So there could be anomalies, for example, as well, like you could have maybe a square plate on a brown table, or you could have a round plate on a table with a green tablecloth. So the more examples that you give the computer, the more it starts to understand about these different variations as well. And after, you can give it a million pictures and a lot of data, and it will crunch for 3 or 4 days really, really hard and put some smoke out. And at the end, it's like the microwave. You have a kit, you have just a file. The file could be 16 megs or 100 megs, and it's a model file. And that basically means that when you give this, when you load this file into a program and you give it a picture, it will return to your results. And usually in addition to the artificial intelligence, the idea is you build a program, okay? So the program can be a program that runs it on a camera or a smartphone or a computer or on the cloud. And basically the program is loading the model, it takes in a picture, and it gives you back data, which is what's in the picture. So just a little bit of an overview about what's behind the artificial intelligence that we're using. And we've used this to find potholes where we're located. So our R&D center is located just outside of the city of Toronto. This is in Ontario, Canada. And the city has about 2.8 million people that live there, has about 5,000 kilometers of roads, and it's a single-tier municipality, meaning that it's responsible for all the roads there. There's no regional and local governments there. It's one government, and they're responsible for everything. They have aging infrastructure. The weather here can be a little bit rough. We have a lot of freeze-thaw cycles, so that means that it takes its toll on the roads. The water seeps in, freezes, pushes the asphalt. The cars, there's a lot of traffic. The cars hit it, and there's a lot of potholes. So I think they estimate in that city that there's about 200,000 potholes a year that they have to patch. And we saw this as a great opportunity. It's a really, really common problem. It makes it to all the news outlets. So we figured if it's so big of a problem that it's in all the news, maybe there's a problem that needs to be solved here. And the way that we solve it is with our AI platform. So we have this studio, which is what you've seen before. It's our program where we mark things in it. We use it initially for security systems, but we've expanded it to also work with data that we collect from smartphone. We have people that basically mark things in the pictures, and then the computer basically takes this new data, crunches the numbers, and then basically learns from mistakes or from right guesses, and over time it gets really, really smart at finding things, all sorts of things like signs and potholes and manholes, and you imagine it, meaning if you can see it and it's visible in the camera, then the artificial intelligence could be trained to find it as well. And the way that most municipalities actually deal with potholes is through sending inspection vehicles. So the number one way actually to learn about potholes today is a 311 system or a service ticket system. Somebody trips or somebody sees it, they have an app or they call, the municipality learns about the issue and it can basically take care of it. Some municipalities also have what's called inspection vehicles. So they say, okay, your responsibility is to make sure that everything is in order in the city. So please make sure you cover all the roads, operate the vehicle safely. Don't get into any accidents with cars or pedestrians. Keep an eye on your mirrors to see that you know, everything's okay. And for most people, this is a challenge on its own, right? To drive safely. For me, for example, if I drive for anything more than 10-15 minutes, my mind starts to wander off to all sorts of things. So the inspectors, of course, are professional. They look for issues, but it is challenging to look to drive for a long period of time. And then on top of it, we say, okay, guys, when you're out there, please look for potholes, look for debris, look for hazards that we need to take care of. We want our city to be safe. We don't want accidents. We don't want claims. So please let us know about these issues if you find them. And since you guys are out there, why don't you help us to find all these different things that can make us run our city more efficiently. You know, let us know if there is roadkill that needs to be picked up, if some of the catch basins are clogged, if the crosswalks are faded, if somebody decided to put a container on the road and blocks the road. And obviously, when you ask somebody to do so much and drive a vehicle and report all these things, you're going to get some stuff missed, right? It's just, it's impossible for a person to be doing all of that and not miss stuff. So the way that we decided to tackle this problem is we said, okay, we have today awesome hardware. When you look at smartphones today that are, for example, made by Samsung. Samsung is a multi-billion-dollar company. They probably, I think they actually spend the most money on R&D out of any other company in the world, at least on some years. And their phones have the best cameras. They have really great GPS. They have really good processors and reception. Why not use their phones to collect data and to find it? And we're more of a software company. We're not really on the road that much. So we have partnered with the city where we are located. It's called the City of Richmond Hill. So City of Richmond Hill is basically a city in central Ontario near Toronto. And there's about 280,000 people, I think, that live there, and about 600 kilometers of roads. We have partnered with the road operations manager there, Bob Levesque, who's now the director for infrastructure delivery. And they said, yeah, this is a nice nice thing for us to try to solve. Let's do it together. The idea is that the smartphone in the vehicle identifies potholes and other issues in the future. And this is great from an operational perspective. It's also great from a political perspective. So this is the mayor of the city of Richmond Hill basically discussing our collaborative project with Visual Defense and the city of Richmond Hill. And we launched this project together. And around that time, we also collaborated with an industry association, a municipal association that is responsible for 428 out of the 444 municipalities in Ontario. It's called the Ontario Good Roads Association. And we asked them, what do you guys think about technology like this that helps local governments to provide better service levels by reporting issues automatically? And they told us, listen, that the idea is a great idea. Obviously, we wanted to improve safety and reduce cost of ownership for assets like roads, and this looks like it's in line, but don't limit yourself to working with one municipality, Richmond Hill. Try to work with as many municipalities as possible. Roads can be in different conditions. You have different people you're dealing with. They may have different processes, different technologies that they're using, different vehicles, and different feedback you're going to get. So the more municipalities you're going to be working with, the better your system will become. So we launched a work group. These are some of the original members of the work group. So it's a bunch of cities and towns that are located around our office. And that was launched in February last year. And as of today, we have more than 70 plus local governments in the United States and Canada. The largest cities we're working with have over 5,000 kilometers of roads and millions of people that live there. The smallest local governments we're working with are townships with less than 100 kilometers of roads and small populations, 1,000 to 3,000. And our work group is really meant to take a new technology like ROVER, which is completely new and it collects so much data, and work together with everybody to figure out what's the right way to handle it, what's the right way to work with this data from efficiency perspective, from work management perspective, from budgeting and planning. What's the best way to use this data in a way that's not going to result in more claims and issues for the government, right? In some places, there's a certain legislation about maintenance levels or about service levels or about standard of care. So when you have this data become available to you, how can you process it in a way that will allow you to work better, but not assume more liability? So the work group has been growing really, really well. And this is just in 1 year, so I do believe that we will blow past 100 local governments before the end of the year as well, if not significantly more. And the way that the technology works is we basically put the smartphone in a vehicle. It looks like this, so there's the mount and the smartphone basically that's right there. You put it in an inspection vehicle, it drives around the municipality or in the local roads or county roads, and it picks up the potholes and put them on the map. We're starting to get to the GIS part, which is of course really, really important because that's the best way to present it. And the idea is that it can pick up potholes way faster than any person can, right? If you're looking at the road where people are going 80 miles per hour, it's really, really hard to basically stop and log every single pothole on the road. So typically speaking, you guys know that there's a problem in this road, but you can't quantify it. You can just say the road's not in good condition, but what's not in good condition, that is something that is not objective. So there are some ways to handle it. Usually local governments either hire engineering survey companies to come and survey the roads. This is done typically between every year to every 10 years, depending on the size of the road network and the budget, and of course how busy the roads are. And technology like ROVER is really supposed to give you a more real-time snapshot about what's going on the road. So you don't need to wait for these periodic every year survey. You can know every week about your condition of the road. And ROVER is pretty cool in the sense that it does everything on the phone, right? So you guys might be familiar with some systems that basically collect for you a lot of sensor information, LiDAR, video, you collect the data, you bring it to your vendor, they upload it somewhere, You wait for a couple of days while they process it, and you get a report, but it's not really real time, and it's really costly, and it takes time to do it. This is a different approach of doing it. So the idea is, and by the way, here, Scott, you asked about signs. They're coming as well. You can see that we have some detections of signs that Rover has picked up. And the idea is that Rover basically can be taught, as I said, to find everything in pictures. We're basically collecting this information. So in a use case in a city, basically it gets installed on the windshield in the vehicle. The vehicle is driving around. Rover is picking up potholes that it is seeing. And basically every time that you see a box flashing, for example, with a pothole, that means Rover has taken note of that pothole. It saved the picture, it saved the GPS coordinates. It knows exactly which road this was on, and it starts to collect this information and upload it to a cloud. And Rover uploads it to a cloud when the data is available. So even if you don't have good connectivity all the time, it will queue the data until it can send it, and then just upload everything in one shot. And then you guys can just go on the cloud and take a look and see exactly what's the condition of the roads. So I'd like to say that Rover is really not a surveying solution. It's more of incident management system or incident data collection system. It's a different way of doing things. Rather than wait for people to complain about issues on the road, it finds them automatically, logs them. If it misses something, then it will pick it up the next time the vehicle drives by, or when another vehicle with Rover is driving by, it will pick it up. It doesn't require anything extra because all local governments have vehicles driving around all the time to take care of stuff, and they do it frequently. And the nicest thing about this is just an app that's running on a smartphone and connects to the cloud. It doesn't require a lot of IT changes. You don't need servers. You don't need to open ports in your firewall. It's just completely a separate system that collects this data for you, generates for you issues and reports and data that you can work with, and it can tie into a lot of other systems, whether it's GIS or work management or asset management. And this is just another sample of basically what a deployment could be looking like, right? So you could have, for example, a patrol vehicle pick up potholes. You could have a garbage truck or a waste disposal vehicle that's going on the road network every week, pick up issues. You could have a bylaw enforcement vehicle go through, and as these vehicles are going around the city, what ends up happening is you're getting full picture of what's going on. And what we actually do is we collect this data and we aggregate it based on certain things like service areas, road segments. We can keep track of how fast these incidents are being opened or closed, so that allows you to monitor service levels. And there's really a lot that can be done with just the processing of this data. And if you're interested to see exactly how Rover works, it's a multi-tier system, which means that basically what we have is we have a smartphone. The smartphone has the app, and what it does is it looks for issues like pothole. And when it finds something that it thinks it's a pothole, it does its best to make sure it's a pothole, and it sends it up to the cloud, it uploads it. Rover does make sometimes mistakes, like it may think that a manhole is a pothole, or if you have a light pole and it's noontime and the sun's shining really bright, then the shadow can look a little bit like a pothole too. A fresh asphalt that you've used to seal the road sometimes can look a little bit dark. And of course, sometimes there's really smaller deficiencies that do get picked up. And what we do is on the cloud, we have a system that basically reviews all this data and rejects it automatically. It's more artificial intelligence on the cloud. And at the end, you have an interface where you can basically look at the issues and decide which ones of them get taken care of immediately, for example, a large pothole, and which one of them maybe it's good to know about, but this could be aggregated into a patch program, for example. And the way that it works is you can put it on any type of a public service vehicle, whether it's municipal vehicles, public works vehicles, utility vehicles, waste management, public transit. Rover is driving around picking up potholes. We do have a really exciting project as part of our work group that now we're working on adding all these extra capabilities as well, like issues with signage, issues with manhole, debris and other things as well to be able to plot them. From a map perspective, these are different layers that you can deal with. You know, you can deal with signs and issues that they have. You can deal with manholes and issues that they have. You can identify locations of potholes. And as soon as you have this data, this is GIS data, you can do all sorts of wonderful things. Like you can try to figure out which locations have the most potholes and send the service crews there to fix them. You can try to figure out a route that is the most efficient for your staff to go to close some of these issues. You can basically see which of your things were inspected more often and which ones were not, to create like a manual inspection list. So there's all sorts of amazing things that you can do with the data that you're collecting as well. Okay, and the way that our partner municipalities are basically using it is they're using it to plan better. So for example, if you know objectively that you have, as an example, 2,000 potholes on your road, and you have a certain budget and you know what the cost to close a pothole is, you could see whether your budget basically allows you to close all these discontinuities and potholes on the road and patch them. And then, for example, you can either ask for more money from the municipality, saying like, this is the number of potholes objectively counted, this is the money that we have, this is what we can do with this money. So it does help with budgeting, right? Do we need more budget, or are we okay with the roads being in a slightly worse condition, right? It's a decision that somebody needs to make, but at least it's objective. So it gets a little bit harder to say, okay, the roads are really, really bad because they're not being fixed. Now you can know exactly why they're not being fixed. You can plan your crews routes better. You do have records, so the idea is when you start to collect this information in a digital format and not pen and paper, you can start to measure continuous improvement in the condition of the roads and how fast incidents are closed. And what this allows you to do is it allows you to create and measure actually service levels that you have, which are also really important. So Rover basically, this leads us to the last part of the presentation. Detecting potholes and other things is just the tip of the iceberg. Rover can do this quite efficiently, but there are all these other things that basically are involved to use the data, whether it's to manage the data securely, how long you want to use it, privacy, right? Like how do we keep the data only as long as we need and for what we need to do it? How do we connect this data with other systems? So I just want to mention Rover has an integration interface that basically allows to get this data out into work order systems, service ticket systems, AVL systems. So you guys can work with other vendors to get the benefits that are derived with knowing this data. And of course, we do have capabilities where we, through our own interface, are able to present it, provide notifications about major issues and reports. And the nice thing about the workgroup that we like to do, and just this is more informational, basically we have a kit which looks like this. For each one of our partner municipalities, we send them the kit. The kit arrives at the municipality. We have a manual of some really large pictures that are really, really easy and basically say, attach the mount to the windshield, attach the phone to the mount, power, launch app, and you're good to go. And at that point, we basically provide access. And that basically allows you guys to start seeing this right in our interface or pull the data out to other systems. We're also an Esri partner, so we are working in making this data accessible for ArcGIS and other systems. And yeah, I think overall that's it. If you guys have any questions about the presentation or you'd like more information, I'd be happy to provide it. And thank you for listening to our overview about the technology.